Welcome you all. I am Professor Muhammad Tariq, Department of Economics, AMU Aligarh. Uh, Today we will discuss about asset pricing model. As this is the introductory lecture, we will talk about some of the basic concepts that will be used in the asset pricing model and some simple derivations which will be statistical or mathematical in nature uh, that will be used later on in deriving certain hypotheses related to the asset pricing and certain models. So the concepts are there. First of all, let me talk about why do we acquire asset? Why do investors try to make investment or acquire asset? The investment is being made because it has certain amount of return associated with this. In pure economic terminology, we define investment as change in the capital stock. And change in capital stock is that which is directly involved into the productive process. But here, the individual investor is not involved into direct production. So the investment is being made through investment instruments. So here we'll be talking about the investment instruments in true sense, but loosely we'll be talking about investment in assets. Now the two basic concepts that are there that need to be learned over here is the total amount of return on an investment or investment instrument and the rate of return. The total return R, let it be, this is equal to amount received divided by amount invested. Amount is being invested in the initial time period and amount is being received after one time period. Let us suppose after one time period. It could be even more than one time period. Let amount be denoted by X. So amount received after one time period, let this be denoted by this X1, and amount invested in the initial time period, let this be denoted by X0. So what is this X1 amount received after time period 1? This will be equal to R into X0. Now there is another term which is called as rate of return. This is your total return. This is called as total return, capital R. Now we have another term which is termed as rate of return. This is denoted by, let this be denoted by small r. This is equal to amount received minus amount invested divided by amount invested. So this is equal to x1 minus x0 upon x0. This is further equal to x1 upon x0 minus 1. So this r is equal to x1 upon x0. We have already denoted it by the total amount of return r. So this is equal to x1 upon x0. This is equal to capital R minus 1. Or what you can say, the total amount of return is 1 plus r. So what is again coming back to this equation x1 is equal to capital R, which can be replaced by 1 plus small r into x0. So this is nothing, this is the formula similar to the simple rate of interest and rate of interest formula. So this is the concept, and this a study on this asset pricing. This is being done in three ways. This analysis, asset pricing analysis rather, this is being done, or this can be done in three ways, or this is being done in three ways. One is known as mean variance analysis. Mean variance analysis. The second one is known as utility analysis, and the third one is known as arbitrage analysis. This arbitrage analysis is also known as comparison analysis. Comparison analysis. So here we'll be confining ourselves to mean variance analysis, and in the process of mean variance we will define how to get the mean rate of return, how to calculate the variance of the rate of return, and how this is being helpful in taking the decision with regard to investment in single asset or investment in portfolios. Clear? So this is about the three analysis or three ways in which this analysis is being done. There is a thing that happens in the investment market, and that is known as, most commonly being used, short selling, and this is also called as shorting. There are many investors who do not have their own money, the investors with no money. With no money, or the investors with a small amount of money. They get some amount of margin money. This the brokerage house or the brokers provides this money. Brokerage house or the brokers. So what do investors do? They purchase this brokerage house. They purchase certain amount of. They do not get investors with no money. They do not get the money. Rather, they get, in place of money, they get the assets from this brokerage house. So the investors get the asset from the brokers, and these assets are being sold in the market. And after some time, when there is a change in the price, after some time it is repurchased by the borrower. The broker is the lender, then from lender you have the borrower, and that the borrower sell it into the market, repurchased by the borrower, and it is returned back to the seller. In the process, what happens? Suppose an amount of asset worth value x0 is being borrowed and sold by the borrower, and after time period 1 it is repurchased by the borrower, and the amount is x1 repurchased and returned to the lender. carefully here. If this x1 is less than x0, then in that situation x0 minus x1 amount of profit is there to the borrower. If x1 is greater than x0, then x1 minus x0 amount of loss is there to the borrower. And if x1 is equal to x0, then there is no profit or no loss situation will be there. No profit, no loss situation will be there. So through this is called as short selling or shorting, in which the investors have no asset, they borrow asset from the lender, from those lenders are the brokerage house or the brokers, sell it in the securities market or to other individuals, repurchases when there is a change in the prices, if price goes down, then in that situation there is net gain to the borrower. If price moves up, there is net loss to the borrower. The amount of gain is limited, but the amount of loss is unlimited. The amount of the gain is limited, but the loss could be unlimited. So most of the individual, they avoid to enter into this short selling or shorting, or many companies they also avoid entering into this market, but this is not completely abandoned. So this short selling or shorting takes place. This we can understand with the help of one example. This suppose a borrower is buying some assets of rupees 10 and 100 units of that is being borrowed. So what is the worth? Worth is rupees 10 into 100, which is rupees 1000. It is this is being borrowed by the borrower. Now it is sold, and after some time period, so what is this? In this case, the x0 is equal to 1000. It is being sold into the market and repurchased when the price has gone down to rupees 9. Now the amount to be paid by the borrower in repurchase, paid by borrower by repurchase, this is equal to rupees 9 into 100. This is equal to rupees 900. So net gain to the borrower is rupees 100. So this we can understand with the in another way. Suppose the person who has purchased this asset from the borrower, he has paid 1000 rupees. The person has paid 1000 rupees, but he has received only 900 rupees. So what about the total return to the person who has received 900 rupees? This is x1, but invested initially x0. So this is equal to x1 upon x0. So this is 900 upon 1000, which is 0.90, means the person total return is only 90% of the amount invested by him. And what about the rate of return? Rate of return is amount invested minus amount received by the final person minus amount invested divided by amount invested. This is equal to minus 1.10. So a negative rate of return minus 1.0 with negative amount of money by the if a person is borrowing 1000, so the borrowed amount will be minus 1000. So a negative rate of return of minus 0.10 into the borrowed amount, which will be negative 1000, makes the gain positive, which is equal to rupees 100. So this is the basic concept in shorting or short selling. But whenever this is the case where only one asset has been purchased, but in the market, when we enter into the investment market, the investment is being done into a number of assets. Suppose the borrower is buying in time period 0 the assets, n assets he is buying. So n assets, it will be initial time period x01, x02, x03 and x0n, such that x0i is equal to 1 to n. This is equal to x0. Clear? What will be the exact amount? What will be the amount of x01 or x02 or x03? This will be a fraction of the total asset that is being purchased by the borrower. So what is this x0? x0 can be written like this, that x0 is equal to w x0i, this ith is equal to wi into x naught. A fraction of this, the total asset purchased, is a particular asset. Like x01 is equal to w1x0, x02 is equal to w2x0, and x0n is wnx0. Now, similarly, we can define the term when repurchase take place to reback the amount of assets borrowed by the borrower. So that will be x1i, and this sigma x1i, I is equal to 1 to n. This is equal to x1. And this we have here we have derived this r is equal to rx0. So if you go by this, r is equal to rx0, r is equal to x1 upon x0, this is equal to x1 is equal to rx0. So if a portfolio is being made, if there is a portfolio in assets, or an investor is making a master asset, then in that situation, what we can write down this as sigma x1i upon sigma x0i. Sigma x1i is equal to sigma x1, this is equal to ri into x naught. divided by x naught. What is this? Can further be written as Ri Wi x naught. X naught can be written as Ri Wi upon x naught. So this R is equal to Ri Wi. This being cancelled out. This x0 is fixed amount, so this will be outside the summation sign, so we can cancel this out. We have also derived earlier this R is equal to 1 plus R. Now here the weights which are being assigned to the different commodities, they are being assigned in such a way that sigma Wi is equal to 1. Certain fraction, suppose 3 assets are there, so one asset could be 25%, another 50%, the third one 25%. So all the three comes out to be 100% or 1. So the entire asset is being divided in this way. So R is equal to RWI, and what is this R? This R is equal to 1 plus R, which is equal to sigma 1 plus Ri into Wi, or 1 plus R, this is equal to, you take the bracket, plus Wi Ri. So what is this Wi? Sigma Wi is equal to 1. So this is equal to 1. So this 1 gets cancelled out with this 1, and ultimately we get R is equal to sigma Wi Ri. So we have two results. This R is equal to sigma Wi Ri. We have capital R. This is equal to Ri Wi. Clear? This we can understand with the help of one example. We can understand with the help of one example. Suppose there are number of securities. The three, here we write down the securities. 3 securities are there. This could be any security. You might be investing in it. Assets of Reliance Industries Limited, Adani Green Power Energy. One might be investing in Wipro, Cipla securities, or any other type of Nifty 100 securities, any other type of securities. Suppose this be, there are 3 securities in which investment is being made by the investor, and the number of shares that is being purchased, is 200, 400, and suppose this is 300. So what is the price of these shares? Price of the share is, suppose this is 50, this is 20, this price is 30. Now value, total asset value, okay, or the total cost or the total asset value, this is equal to 10,000. We are considering in rupee terms, Indian currency, rupees terms. So this is 10,000 rupees. This will be 400 multiplied by 20, 8,000, 300 multiplied by 9. So what about the total asset value or the total cost of investment? This is 27,000. Clear? Now weight in the portfolio, Wi, weight in portfolio. This is 0.25, this is 0.50, this is 0.25. So this is the weight in the portfolio, and rate of return. The different assets will have different rate of return. Suppose this is 20%, this is again 25%, this is again 20%. Suppose this is the rate of return, or let this be 15% only. Clear? Now weighted rate of return. Weighted rate of return, if we calculate, this will be 20 into 25, this will be 5.00%, this will be 7.50%, 3.75%. So what will be the total return? Total return will be 16.25%. So this weighted rate of return is 16.25%. This is more than this. So this is sort of average rate of return on all the three variables. As I told you, in shorting or short selling, what happens? The rate of return or the gain is limited, whereas the loss is unlimited. We cannot say anything about the loss. So the return could be positive, it could be negative. Positive means the profit is there on an asset, the return we call it as positive. If loss is there, the return will be termed as negative. And if there is no profit, no loss, so this will be 0. So what do you find? That the return on asset or investment return, it can take any value, positive, negative, or 0. So this follows this type of variable which can take any value, and we are not sure about this, that which value will be there. Positive, how much gain will be there, whether this will be of 2 units or 4 units or 6 units, or if loss is there, what could be the quantum of loss, 3 units or 5 units or 10 units. So it can be any number. So this type of number, this in mathematical terminology, we call this type of variable as random variable. So this follows the characteristics of a random variable. This follows the characteristics of a random variable, the return on an asset. We will talk about some of the characteristics of a random variable. Let any random variable be denoted by this value x. Clear? So how do we define this the characteristics of the random variable, or on the basis of this, how do we calculate the mean value of this, the variance of this, and the covariance between different assets, the return on different assets. So the three things are there: mean, variance, and the covariance, which we'll be discussing about. And this concept we'll be using this early, because what we have talked about, this asset return analysis, it can be done in 3 ways. Asset pricing analysis, that mean variance analysis, utility analysis, and arbitrage analysis. So mean variance analysis we are talking about. Clear? So the mean value, and what is this asset return? Asset return follows random variable. So this we can understand with the help of an example, and the example that we will be taking is about tossing of a die. Tossing a die that we will be talking about. So when we toss a die, the points that we get on the die, let this be denoted by X, points on die. So let this X will take any value 1, 2, 3, 4, 5, 6. And what about this probability of this X? This will be 1 by 6, 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 1 by 6. Like when we talk about the return on asset, positive, or we make investment, we do a guesswork, or we do a scientific analysis on the basis of the past available data, that this quantum of return, every quantum of return, we are not sure about it, so we assign certain amount of probability to that quantum of return. That okay, if this return is there, what is the probability that this much I'll be getting, or the investor will be getting? So certain amount of probability, that is why this is called as a random variable. Random variable means variable with with certain degree of probability. Now if this is X, we calculate the mean value. The mean value of the probability, this is being denoted by or calculated by expected value of X, and we define this expected value of X as Pi xi, I is equal to 1 to n. So what is this Pi in this particular case? It is 1 upon 6. So this 1 upon 6 can be taken outside. 1 plus 2 plus 3 plus 4 plus 5 plus 6, and this comes out to be 3.5. So this is mean value of X. When you toss the characteristics, some of the characteristics we'll be using later on is this expected value of X is nothing but, you can say, this is equal to X bar. Now there is another thing, expected value of any constant number C, this is equal to the C itself. The expected value of constant with X, this is equal to C into expected value of X. The expected value of linear combination of two values Ax, two random variable X and Y, this is equal to A into expected value of X plus B into expected value of Y. So it is like this. These are some of the properties. Clear? So if we throw two dice simultaneously, let the numbers which comes on the die, on one die, this be denoted by X, and the number which comes on another die, let it be denoted by Y. So expected value of X plus Y means the mean value of throwing two die, this will be equal to expected value of X plus expected value of Y. What is the mean value of throwing a die? This is 3.5. So this is 3.5 plus 3.5, which is 7. Clear? Since we are talking about this analysis, mean variance analysis, so mean part we have covered. Let us talk about this variance. What about this variance of X? So the variance of X, this is being denoted by expected value of X minus expected value of X whole square. This is expected value of X minus X bar or so this we can write down expected value of a minus b whole square, a square minus 2ab plus b square. So this we can write down expected x square minus twice x bar, expected value of x plus expected value. X bar is a constant, so the expected value of a constant is the constant itself that we have already talked in the properties. And what is this? This is x bar. So this is equal to expected x square minus twice x bar square plus x bar square. So this is expected x square minus x bar square. So this is variance of x. So when we talk about this variance of outcome of a die, variance of outcomes of a die, what it will be? So variance of x, this will be equal to expected x square, this will be equal to p into x square minus x bar square. So this is 1 upon 6 into 1 square plus 2 square 3 square plus 4 square plus 5 square plus 6 square minus x bar we have already calculated 3.5 square. So if you add all these numbers, this comes out to be variance of x. This comes out to be 2.92. And now what about this? The variance, the unit of measurement of variance and the unit of measurement of the variable itself is different. So in order to make comparable the variable unit or the unit of measurement of mean as well as the variability in the data, we use another term that is known as standard deviation. This standard deviation denoted by sigma, this is nothing but this is a square root of variance of x, and this variance of x is 2.92, which is equal to 1.71. Clear? So this is all about the variance. Now there is another term which is known as covariance. When we have the two variables simultaneously, when you toss two, when we toss two dice simultaneously, there is another term, or when investment is being made in more than two assets, they may be correlated, they may not be correlated. So the covariance between these two assets, if they are not correlated, will be 0. If they are correlated, it will be either positive or negative, and the values for this will lie between -1 and +1. So the covariance between two variables x and y, or x1, x2, this could be expected value of xi minus x bar into yi minus y bar. So if you take this, multiply this, you get this expected value of xi yi minus xi y bar minus x bar yi plus x bar. You take the expected value of xi yi minus y bar is fixed, expected value of xi minus x bar, expected value of yi plus x bar y bar. So this is equal to x bar, this is equal to y bar. So one x bar y bar cancels out another. So what is this expected value of xi yi minus x bar into y bar. Clear? So this covariance between x and y, this can be denoted by this sigma x into y. This sigma x into y, this could be equal to 0, this may be positive, and this may be negative. If this is equal to 0, no relationship between x and y is there. In that situation, expected value of xi, yi, this is equal to expected xi into expected yi. So this terms comes out to be, covariance comes out to be 0. So if this is positive, this means if any value of x, any x is greater than average x, then in that situation the value of y will be greater than the average value of y. Here any y value, if this is any x value, if it is greater than x bar, then y value will be less than y bar. So these are the few of the concepts that we'll be using. Thank you very much for today's lecture.